Welcome, science friends, to pedigrees. Pedigrees are diagrams that follow traits through a family. Circles and squares represent people. Women are circles, men are squares. When circles and squares are shaded, that represents people that are expressing the trait that we are following. We can't follow all traits. Pedigrees are just to follow one specific trait. If we see a half-shaded symbol, it doesn't matter if the shading is on the right or the left. If it is half-shaded, that represents a carrier. So that almost always means females. We can use pedigrees to track any type of inheritance. So here is a pedigree of Queen Victoria's family. Here we're back looking at hemophilia. There's a little key at the bottom here where it's telling us what normal males and hemophiliac males look like, normal females and carrier females. There aren't any examples of hemophiliac females in this pedigree or family tree. It's kind of incredible, but if you look closely, all of those who have hemophilia are males. And all of those carriers are producing at least one descendant with that hemophilic trait. So it's kind of cool that we are seeing the effect of carriers on this trait. So let's do a little pedigree practice. Looking at this pedigree, we should be able to determine the inheritance type. Are we looking at a dominant trait, a recessive trait, something that's sex-linked? And we should be able to explain how. So we need to determine if we're looking at a dominant, recessive, or sex-linked trait. Our first big clue are those half-shaded circles. If there are half-shaded circles, that means females are carriers. Carriers usually mean sex-linked. The other thing we want to look for is those that are affected. All of the fully shaded squares that we see are male. And if it's male, oftentimes that means it's going to be sex-linked because they only have the one X chromosome. Whatever allele they have on the sex chromosome is what they express. Lastly, we need to figure out if this sex-linked trait is dominant or recessive, and based on this pedigree, we can safely say this is a recessive trait because it's not affecting as many as the unshaded. So because it's affecting fewer of our individuals, it's most likely going to be a recessive sex-linked trait. Looking at the next example, we can figure out, okay, we don't see any half-shaded, so we're looking less like a sex-linked trait, and we're seeing a male and some females that are affected, so I'm going to go ahead and we're just going to assume that this is not going to be sex-linked. Also taking a look, well, we see the majority, 4 out of 6 or 2/3 of our individuals on this pedigree have the trait. Therefore, we can safely assume it's a dominant trait. We also know that our parents, numbers 1 and 2, are going to be heterozygous for this dominant trait because they produce offspring that do not have that dominant trait. In our next example, we'll be examining a widow's peak. Widow's peak is when your hair comes to a point kind of at the top of your hairline. I have a widow's peak. So we need to figure out what kind of inheritance we're looking at. Our first clue, we're not seeing any half-shaded circles. We're also not seeing primarily males with this expression. So we see no half-shaded circles, and we see both males and females expressing this trait. So it is likely not sex-linked. Taking a look, we see all of those with a big W are expressing the trait. So we can assume that this is a dominant trait being passed down through generations. Our next example here, again, if we want to determine if it is sex-linked or not, looking at our pedigree, we're not seeing any half-shaded circles, and we're seeing both males and females expressing this trait. We now need to determine if it is dominant or recessive. Once again, looking at how the shading is, we see that those with homozygous recessive genotypes, little f, are the ones that are shaded, so therefore this is going to be a recessive trait. Now let's practice making a pedigree. We're just going to do 2 generations. It's to help practice what all of those little lines mean and how to construct one. So we have Douglas and Lauren. They get married and have 3 children, 2 girls and a boy. Douglas is a male, so he gets a square. Lauren is a circle because she is a female. They are the ones who are making offspring, so we put a horizontal line between them. That indicates they are creating a family. We bring a line down from the middle of that first horizontal line connecting the 2 individuals, make a third line, this one is the second horizontal, and from there we're going to put our children. Children are going left to right from oldest to youngest. So their first oldest child will be a female, their second middle child is also a female, and their third last child will be a male. Now let's follow a trait. Douglas has brown hair. Well, if brown hair is the trait that we are going to investigate, we need to shade in Douglas's square. He has the trait, he is expressing the trait that we want to see. Lauren, who does not have brown hair, we'll say she has blonde hair. She does not have the brown hair, so her circle stays open and unshaded. Now, we're looking at their children. It looks like the oldest daughter and the youngest son have the brown hair also. So if they have the brown hair, they need to be shaded in as well. Lauren and the younger daughter, the middle child, have blonde hair, so they do not get shaded in because they do not have the trait we are following, brown hair. That was Pedigrees. I hope it helped.